This is for Algebra 1. We're looking at the worksheet called Wandering Walkways. A memorial walkway is being planned to surround the reflecting pool in Washington, D.C. using a pattern of triangular tiles and hexagonal tiles in the stages shown below. The base edge of each triangle is 2 feet, and the diameter across each hexagon is 6 feet. So across here is 2, and across here is 6. So we've got 2, 6, and 6. We've got 2, 6, 6, and 6, if that matters. So they want you to complete the table. In stage 1, that would be your first picture. Okay. The number of triangles that you have would be 1, 2, 3, 4. The number of hexagons would be 1. And the center length would be 2 plus 6, which is 8. In stage 2, we still have we have 6 triangles because we have 4 here plus 2 here. We have 2 hexagons, and we have 2 plus 6, which is 14. In stage 3, we have 4, 5, 6, 7, 8 triangles, 3 hexagons. 2 plus 6 is 20. So to continue, you could draw if you wanted, or look at your table and see if you see a pattern going. 4, 6, 8, it's going up by 2s, and so we would go to 10, and to 12, and to 14. Now to figure out what goes here, you kind of got to compare it to your stage. Okay, what did we do with 1 to get 4? What did we do with 2 to get 6? What did we do with 3 to get 8? Okay, if you're not sure, you could also put these in your calculator at STAT. And you're going to have 1, 2, 3, 4, 5, and 6. And then you're going to have 4, 6, 8, 10, 12, 14. Then you're going to go back to STAT. You're going to go over to Calc, and you're going to choose number 5 if you want. A is 0, so there is no x squared. It's not quadratic. B is 2. C is 2. So that should be 2x plus 2, which is exactly what they showed. For the hexagons, we go from 1 to 2 to 3. Looks to me like we're going up 1 each time. If you compare that to your stage, it's the same, and so x is just x. We went from 8 to 14, so we added 6. To 20, we added 6. If you add 6, you'll get 26, 32, 38. If you know what the equation is, fine. If not, then let's go back to STAT. And we'll leave our x, or our L1, alone. But over here for L2, it's going to be 8, 14, 20, 26, 32, and 38. Back to STAT, over to Calc. Go ahead and choose 5 just because you're not sure. A is 0, so it is once again linear. B is 6. C is 2, so this is 6x plus 2. So you find the pattern to extend your table, and then you put it into STAT to get your function rule or equation that goes at the bottom. So we know the number of triangle tiles is 2x plus 2. The number of hexagons is x, and the center length is 6x plus 2. So now we're going to answer questions about this. What are the independent and dependent variables? Remember, independent is always your x, so it's always going to be the word above the left side. Okay? So what word do we have? We have like stage written over here. So independent is stage, which makes your shape your dependent. An appropriate domain and range, go back and look at what's on your table. Okay, it gave you a set of pictures or a table, therefore your domain and range will be probably a list. They're going to say x is greater than or equal to 0 in integral values. That would be the same thing as a list if you went 0, 1, 2, ... Your range is going to be y is greater than or equal to 0. Once again, it could also be written 0, 1, 2, ... I like the idea of using a list on this better because they did not give me an equation. They gave me a set of pictures, and you're not going to have part of each stage. Number 4, when looking at the relationship between stage and shape, is the data continuous or discrete? We haven't talked about that in a while. Discrete data is when you cannot have part of it. It's like people. You either have someone here or you don't. Continuous is something that you can measure and you measure part of, like miles, okay? Distance is usually going to be continuous. This is discrete data because you're not going to have part of your stage or part of your shape. How is the number of triangular tiles changing per stage? What is the rate of change? Rate of change, remember, means slope, which is the number in front of x. And so if you look at triangle, it's 2x plus 2. How's it changing each time? What is your slope? Well, the number in front of x is 2. So your answer here is 2. What generalized formula can be used to represent the number of triangular tiles versus the stage number? That's where we put it into stat. We've got the equation written at the bottom. It is 2x plus 2. How's the number of hexagon tiles changing? What is the rate of change? Once again, look at the bottom of your table. You have an equation there. X is your equation. What number is in front of that? A 1. Therefore, your rate of change is 1. What generalized formula can be used to represent the number of hexagons? That's what we wrote at the bottom of the table. It's x. Determine whether each relationship is proportional or non-proportional and explain your reasoning. Remember, a proportion is 2 fractions. They have to reduce to be equal to each other or cross-multiply and get the same. And so they're saying that the first one, which is h of x, number of hexagons, is proportional. It is linear, it has a constant of proportionality, and it goes through the origin, okay? Linear, has a constant of proportionality, and goes through the origin. That is what makes it proportional. Okay, the next one is not, and technically, the reason it's not is because of this plus 2. It does not go through the origin. How many triangular tiles and hexagon tiles would it take for stage 52? You would just either, probably the best thing is to put your equation into y equal and go to where x is 52. We know that for a triangle, it was the formula 2x plus 2, and for hexagons, it was the formula x. So we know that hexagon should just be 52, and the triangles would be 2 times 52 plus 2, and you would get 106. Will any stage require exactly 82 triangular tiles? Well, what you have to do here is go to your y equal and clear everything out. And my equation for triangle was 2x plus 2. And we're asking about 82. And then I'm going to go second calc, let it draw. 5, enter, enter, enter. I'm just finding where they cross each other. I thought. Looks like I'm redrawing it. Second calc. Second. Actually, let's just go zoom 3 for out and hit enter until I can see both of my lines going. Go ahead and enter again because I still just see one. Now I can see them both. So second calc 5, enter, 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 and I get 40. So your answer here is yes. At stage 40, it's going to require exactly 82. What generalized formula can be used to represent the center length? That's what we did in the last column and where we got our 6x plus 2. We just went to stat. If the distance around the reflecting pool is 7838, how many triangular tiles and how many hexagon tiles will be needed? You're going to go back over here, and you're going to put 2x plus 2 for y equal, and you're going to put 7838, and then you're going to go second calc 5, enter, enter, enter. And if it does that, you're going to have to zoom out until you can see both of your lines. So I'm going to enter and zoom out again. And I'm going to enter and zoom out again. Finally, I can see both. Second, calc 5, enter, enter, enter. And I get 3918. So if you look at this, they used, okay, we used the wrong formula. Why did we use the wrong formula? They want to know, or what they gave me was the distance. If you come back over here and look, this is the only one talking about distance. This is what it should say at y1, 6x plus 2. So go back to y equal and change that to a 6x plus 2. And then you do your second calc 5 and let it draw. Enter, enter, enter. And you get 1706. I'm sorry, I read it wrong. 1306, which is what they got. So it would take 1306 stages. The key thing there is to make sure and put the correct formula at y1. Look at what they're talking about. Okay, so what you're going to do now is a worksheet that is called Linear Functions at the Tanks. Kleberg Refining has 2 equal capacity gasoline storage tanks in the loading rack area. At the beginning of the day shift, tank A is full. It is being used to fill the tanker trucks at a rate of 12,000 gallons per hour. Tank B is empty, and it's being filled with gasoline at the refinery at a rate of 18,000 per hour. So one tank is full and we're taking it out, which would be subtraction. The other one is empty and we're putting it in, which would be addition. So independent and dependent, look over here. Remember, we don't do the process columns. Independent is always in front of X. It's always the first column. So if you will look here, you will notice that it is time. Dependent is the other one. It's the last column. It's Y. In this instance, it's gasoline. So at the beginning, for the first tank, we have 1,080,000 gallons in there. We're taking it out at a rate of 12,000, so that it becomes 1,068,000, 1,056,000, 1,044,000, 1,032,000, and 1,020,000. Then the other tank is empty to start with, and we're filling it at a rate of 18,000. So after 1 hour, it's 18,000. After 2 hours, it's 36,000. After 3 hours, it's 54,000, 72,000, 90,000. Okay, so we've got your tables filled in. Now you're going to have to look at those tables to figure out your domain and range. Remember, domain is X, range is Y. You're going to plot the points. And then you're going to go to the back of the page and you're going to make a graph and you're going to answer questions about this. And then it gives you one more situation at the end where they want you to look at the night shift. Okay, if you want to look at this to fill in your table, that's fine. And then you will use stat to get your function. Remember, a function is just an equation. If you have questions, call me over.